Hello class, today we're on lesson 3 of chapter 6 and we're going to be doing graphing linear equations, and we have a cartoon here with Broomhilda, and she's rolling a dice, and she's playing a game of dice, rolling 2 dice, and she gets a 3, then she gets a 9, then a 7, and then she says, I seldom lose. Now, let's read on. Broomhilda's system for winning a game of dice by throwing a 7 seems to be based on the principle, if at first you don't succeed, try again. If 2 dice are thrown, in how many different ways can they land so that the sum of the numbers that turn up is 7? One way to answer this question is to make a table, letting x represent the number of one die and y represent the number on the other die. So we have here the table of x, y, and we can see where x value goes from 1 to 6, and as it's rising from 1 to 6, the y value is going from 6 to 1. And we would know that we have the formula x plus y is equal to 7. It says the table shows that there are 6 ways in all. The question that we have just answered is equivalent to asking how many different solutions that the equation x plus y is equal to 7. So we have 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, and 6 plus 1. Okay, and so it's equivalent to saying how many different solutions that the equation x plus y is equal to 7 has if the solutions are restricted. Okay, here they're telling us we're only allowed to use certain types of numbers, the pairs of positive integers. So x and y both have to be positive integers, because the truth is we can actually have quite a few different answers here. In fact, we know that there will be an infinite number of answers, but we know that the dice, the numbers only go from 1 to 6, and they're positive. So we are restricted in using pairs of positive integers, and we see that the solutions are such, and they've been graphed over here: 1, 6, the coordinate 1, 6, the coordinate 2, 5, the coordinate 3, 4, 4, 3, 5, 2, and 6, 1. If we think of each ordered pair as the coordinates of a point and plot the 6 points on the graph, we find that they lie along a straight line. The graph is shown at the left, and the 6 points in this graph show all the solutions of the equation x plus y is equal to 7 that are pairs of positive integers. Okay, we just add that on. We have to say that because x plus y is equal to 6, we can do quite a bit. We can use negative 100 and positive 107. That would give us an answer. But again, only pairs of positive integers, and that would not work because negative 100 is not qualified within the restrictions that we have. What would happen if we drew a line through the points and extended beyond them? The result is at the right. This line shows where all of the solutions of the equation would be if we did not restrict them. Okay, if we did not restrict them to pairs of positive integers. Point A, for example, has coordinates negative 2, positive 9. And negative 2 plus positive 9 is equal to 7. Points B and C have coordinates 2.5 and 4.5. And 8 and negative 1. And again, we have here, plugging in the values into the equation, we can see that 2.5 plus 4.5 is equal to 7, and 8 plus negative 1 is equal to 7. Because the line shows where all the solutions of the equations are, it is called the graph of the equation. Again, because the line shows where all of the solutions of the equation are, it is called the graph of the equation. Other equations having graphs that are straight lines are x plus 4y is equal to negative 2, 2x minus 7y is equal to 0, 5y is equal to 8. Notice that there's no x there. X is actually 0. And y is equal to 3x plus, or excuse me, y minus 3x is equal to 5. It is possible to prove that the graph of every equation equivalent to an equation of the form ax plus by is equal to c is a straight line if a and b are not both 0. For this reason, such equations are called linear equations in 2 variables. A linear equation in 2 variables written in the form ax plus by is equal to c is said to be written in standard form. Okay, so let's take a look at this form again. And remember, we talk about forms as being what they are. They are not necessarily the equation, it's actually the form. This is what the equation looks like. Okay? And let's go ahead and write. We have ax plus by is equal to c. Okay? Now, if we were to look at equations that are written differently, we can always put them into this form. And that's what we're going to do with the example below. Now we understand what we did here in graphing because we pretty much did what we did in earlier chapters in terms of graphing. We understand how to create a table X, Y. We understand how to plot those points over here on the graph, and you know, you get your ruler. We've dealt with linear equations. We've dealt with the forms. Now we're having a form which has two variables, not just one variable. So let's take a look here at example number 1. It says here, show that each of the equations listed in the preceding paragraph is a linear equation in two variables by writing it in standard form of such an equation and giving the variables a, b, and c. So the first one they ask us to do is we have x plus 4y is equal to negative 2. Now we can easily see that this is already written in its form. We might say, well, what is the a and what is the b and what is the c? What are these constants in this particular form? And if we take a quick look, we would know that x really all by itself is 1 times x. That's the first observation we need to see, because we might say, well, there is no a value here. Well, there is an a value, and it's actually 1. Okay, so that would be the a value. Then we take a look at the b value. Well, what's the constant next to y? And that would be 4. It's positive 4. It's plus 4. And the last one is negative 2, the c value. Okay, so we're able to plot what the a, b, and c values are. And again, this was a fairly simple equation because it was already written in the form. Okay, now when we look at the next equation, we see 2x minus 7y is equal to 0. Now there's a little bit of a change there. 2x minus 7y is equal to 0. And the change is that this is minus 7y. And we're told that the form is ax plus by. So it's not written in the form of ax plus by is equal to c, and we need to change it. And all we simply have to do here is write it as 2x plus, and you know I like to use my parentheses, negative 7y, because when we go with the opposite, we're going to change the minus to plus. We go with the opposite, which would be negative 7y. We had a minus positive 7y. Now it's going to be a plus negative 7y, and that is equal to 0. Now we're able to much more easily determine that a is equal to 2, b is equal to negative 7, and c is equal to 0. Okay, so we are sometimes going to be challenged to put our equations into the form, and just because they're written in the order x, y, and then you just have a number here, which is c, right, doesn't necessarily mean that it's written in the form. We have to be very careful. Right here, this is the spot. This is a minus, and this is a plus, and we have to change that so that we can then determine. You'll probably get much more proficient with it, and you'll simply see that without having to rewrite it. You'll say 2, that's a negative 7, and this is 0. You didn't necessarily have to rewrite it, but you must be very careful that you don't just bypass that minus sign and say that 7 is the value of b. Now, this is going to be very important, particularly when you get further down into the quadratic formula. And the reason is the quadratic formula is a simple way to solve quadratic equations. This is a linear equation, right? We have here a linear equation. A quadratic equation actually has exponents in it, and it becomes so much harder for us to solve what x is or what any variable is in those environments when we have exponents. And the quadratic formula is an easy, simple way to solve these things, but we have to be learned in or knowledgeable in determining what A, B, and C values are, and understanding particularly what happens over here when we see the negatives. So it's very important that we learn this. We're going to keep this tool in our toolkit. Later on, we'll be able to determine the usefulness of this tool as we go into these much more difficult equations. So let's take a look at our next one. We have 5y is equal to 8. Now you might say, well, there is no x value, is there? And there is no x value there, but we can always substitute by putting it into the form of 0 times x, right? Why? Because 0 times x, no matter what x is, will always be 0. And it would not change the value of this equation, right? So we could then write 0x times 5y is equal to 8. And again, this is where math starts building your knowledge. And your knowledge, this came from again, another previous chapter where we discuss that anything times 0 is equal to 0, and we can create a value that we don't see by using the 0, so that we can now determine what the A, B, and C values are in this particular case, in this form. And in this form, while this is a linear equation, we don't have an A value until we put the A value in for x, which is 0 times x. And again, 0 times x, regardless of what x is, will always be 0. So it's the same equation. These are two equivalent equations. A is now 0, B is 5, and C is 8. Okay, now let's go into the last one. And again, this is another type of equation that we're going to be challenged with. And we're going to have to reorder or place them in the order, the variables, so that we can see them as they should be as it relates to this form. Let's put it into the form ax. We have the y minus 3x. So we have to change this around. And the best way to do this would be, as we can see below, the first thing that they indicate is that this is the same as y is equal, excuse me, not y is not equal to, y plus negative 3x, okay, is equal to 5. Now, why'd we do that? Well, it's the same thing we had over here, where we had 2x minus y, and we turned it into an addition problem, so that we can now handle these two terms any which way we want, because we're adding. If we're subtracting, remember, 2 minus 1 is not the same as 1 minus 2, is it? Okay? We have to be very careful when we're subtracting, and that's what we were doing. But we can say that 2 plus 1 is the same as 1 plus 2. Okay? So we're able to move these terms around when it's in the form of addition. Now that we have y plus negative 3x is equal to 5, we can now change this and simply say negative 3x plus y is equal to 5. We simply were able to rewrite it. We couldn't say 3x minus y, because that would change the equation. But we can say that y plus negative 3x is equal to 5, and then we can simply, because we're adding, simply switch these two over, and now it's in the form. Now you can certainly have the parentheses that I always like to use, but in this case, because the negative is hanging off the left side, we don't need these parentheses. We can just go ahead and write it as negative 3x plus y is equal to 5. Now that means that our A, B, and C values are very clear. They're right in front of us. And what are they? Well, A is equal to negative 3 that we have here. B is equal to 1. And C is equal to 5. Okay, so what you've learned here in particular is how to put equations into the form. And you've done this before. We just need to start refining that skill. And once we've refined that skill set, these become so much easier. Okay, so Let's go over to page 254. I'm going to clear off my screen here. And we'll start working on this example number 2. Now we have here, one way to graph a linear equation is to solve the equation for y and use the resulting equation to make a table. Plot the points of the table and draw the line through them. So we have graph the equation y minus 3x is equal to 5. So let's go ahead and write that down. We have y minus 3x is equal to 5. Now, solving the equation for y by adding 3x, that's what we'll do here, 3x, we're going to add 3x. We'll have y is equal to 5 plus 3x. Now we can certainly choose any values we would like for the value of x, because we're solving this for y. So if we plug in a value for x and we do our math and multiplication in our math, we'll certainly find a value for y for each of these. So create our table of x and y's, and in this case the author chose -1, 0, 1, and 2. So we've got 4 points. And once we start plugging in the values, we put -1. -1 times 3 is -3. So 5 plus -3 is equal to 2. Then we have 0 as the x value. 3 times 0 is equal to 0. 5 plus 0 is equal to 5. Then we have 1. 1 times 3 is 3, so 5 plus 3 is equal to 8. So y is equal to 8. And then the last one, we have 2 times 3 is 6, plus 5, that would give us 11. So now we have a table, x and y values, and we can plot our points. We have our point -1. Let's go over here. We have -1, +2, so we would plot our first point. Ooh, I need to get a black marker now. So this would be our first point, right? And our second point is 0, 5, so we stay on the y-axis and go all the way up to 5, and we can plot our point there. And let's see, our next point is 8. 1, 8, so we go over 1 and we go all the way up to 8, and we could see that our line is forming. Okay, you can see this is going to be a straight line. Our last one is 2 and 11, which would really put us on the very edge. I don't have 11 marked, but pretty much right there. Now, if we got our ruler, and I'll get mine over here, let's see, we can go ahead and connect these, and that would form, oh, excuse me, I have to undo that. It's not a good line, is it? Looks like it just fell off. Let's grab this, and we form our straight line. And again, we know that that straight line really extends infinitely in both directions. You're not going to infinitely represent it because your paper would not be infinite. You can certainly put arrows on the end and pointing as far as your paper would allow. Okay, so this is the graph of the equation y minus 3x is equal to 5. Okay, we've been given another one here. Graph the equation x plus 4y is equal to 8. Solving this equation for y, what would we do? Well, the first thing we have to do is get rid of our x, right? We want the y on the left side, so we subtracted x from each side, and we ended up with 4y is equal to 8 minus x. Then the next thing we had to do was divide both sides by 4, so that we can get y. So 4y divided by 4 is going to give us y, and then we have 8 minus x divided by 4. So now we know what y is equal to. When we plug in values for x, we can solve for y. Okay, so obviously if we had not done this, and if we decide not to solve for y, I mean, we can certainly solve it for x as well, but this is just the standard way of doing it. But let's say we did neither. When we put in a value for x, it's going to force us to do all of the math that we just did to solve for the other variable. So let's say if I kept it in the original equation of x plus 4y is equal to 8, which is the original equation here. Imagine I put in a value for 1. Now I have 1 plus 4y is equal to 8. Well, guess what? Now I'm going to have to subtract the 1 from each side, and I'm going to have to divide each side by 4. So rather than doing that for each value, we simply solve the equation itself. And that way, when we plug in the value, we're steps ahead instead of repeating these steps over and over and over. So this is why we solve for y. And now we see choosing some of the values for x and using the equation to find the corresponding values for y, we have this table, this x and y table. They use the values 0, 1, 2, 4, 8, and we see the y values that correspond to each of these. And now you can see that they've plotted the 5 points and they have the graph on the right. So simply this is a way for us to graph a linear equation. Now, one of the things that I'll tell you is that you're doing this really the hard way, but it's important that you do it the hard way so that you get familiar one, with solving equations. We're reinforcing solving an equation for a variable, which we learned in the previous lessons. And then we're getting more familiar with the graph, which we did again in previous chapters, and we're bringing back those graphs so we can see how the graph relates to the equation. What we will learn in the next lesson and the subsequent lessons is an easier way to do this. But it is important that you do it this way, but I promise that by the end of this chapter, I'm going to give you the easiest way without having to create tables, without even having to do math, let's just say, to some degree. But we're going to focus on what we've been given here, and we have set 2 exercises, which I'll make another video for.